Okay, let's get started. So in this lecture, we're going to talk about MapLibre. So this is a Python package that allows us to create interactive 3D maps. In the previous lecture, we have covered how to use leaf maps to create two-dimensional maps. So leaf map provide a couple of mapping backends. And the default one is using IPyLeaflet. So IPyLeaflet, the Python package is built on top of Leaflet JavaScript library. And very much similar here, we're going to use the MapLibre Python package. And the MapLibre Python package is a binding for the JavaScript library. So if you click this link, it should take you to this website here, MapLibre. So basically, it's an open source TypeScript library that allows you to create interactive maps. And particularly, this is one of the very popular libraries for creating 3D maps, and it's free and open source. If you have never heard about MapLibre, you probably have maybe heard about Mapbox. So Mapbox is another very popular geospatial toolkit that allows you to create all kind of 3D maps. And Mapbox used to be open source, but a couple years ago it changed to closed source, and this is where MapLibre comes in. So basically, MapLibre built on top of the open source version of Mapbox before it converts to closed source. And so this is more like community maintained, and it's the base 3D libraries that you can have. It's free. You can use it for any commercial applications without having to pay a license. And so what we're going to do in this lecture is going to utilize the MapLibre Python bindings. And if you click the link here, it will take you to this GitHub repository. So this is an open source Python package that built on top of the JavaScript libraries, and LeafMap built on top of this one makes it so much easier to create interactive maps. So you don't have to learn all of this. In general, the source code you're going to utilize in this MapLibre Python package is going to be a little bit longer or complicated compared to using LeafMap. So this is what we're going to cover today, is just to basically utilizing the LeafMap backend. So previously, we mostly just import LeafMap, then you can just create maps. But we need to do this one, which can import leafmap.maplibre as leafmap, and then everything else remain the same. So it's very easy and very intuitive. And so to follow through, you can either use Google Colab or you can run it on a local computer. Keep that in mind. MapLibre built on top of another package called AnyWidget. And right now, it doesn't work on VS Code. So for this particular lecture, you need to use JupyterLab. Okay, so don't use VS Code because it's not going to work. But you can use Google Colab. So if you open the Google Colab, and then from here, you can just, let me see here. You can uncomment this one to install the MapLibre backend. So it's going to include install LeafMap and also MapLibre and also some additional packages. So just click this one, run anyway. And so it should take a couple seconds. If you can also install this one on your local computer if you have not done it before. You need to update the LeafMap to the latest version. So right now, the one that I'm using here is 0.38.11. So this is the latest version that I just released a couple hours ago. If you trying to run the notebook, if you run into any errors, so it might be because your LeafMap version is a little bit outdated. So you might want to just run this command line to install it. And after you install the packages, the other thing that I want to mention is that for some of the maps, all the maps that you're going to run within Google Colab, you cannot do the full screen. I'm going to show you shortly. So if you want, you might need to use the other way. So after you finish the installation, just restart a section. And so let me scroll back to the beginning here. Then you can clear all the outputs. After that, just import the library. So just remember, import leafmap.maplibre.gl as leafmap, then you should be good. So after that, these are the syntax that we have utilized in the previous lectures. It's very much similar. The only thing that you need to pay attention is that previously using leafmap, so the convention when you're trying to create a map, the center and the zoom level, So the center will be latitude and longitude. Okay, so here will be the center 40-degree latitude and negative 100-degree longitude. But MapLibre uses a different convention, so it uses longitude and latitude. So this is something you do need to pay attention, otherwise your map is not going to work. So by default, if you don't provide anything, it's going to be latitude 20-degree and longitude 0-degree. So the default map will look like this. So this is the map that you're going to see. You're going to see it by default when you create the map. So this is by default using the CartoDB dark matter vector tile. So you can zoom in, you can zoom out, but you can also specify a center and also the zoom level. So again, make sure this is longitude and latitude, basically X and Y. And you can also specify the zoom level, the pitch, and also the bearing. I will talk about what does that mean. So for example, this right now, center around the US compare to MapLibre is 40 and negative. So it's reverse. So make sure that you follow the instruction here to create. And so you on the right here, you see the full screen. So very much similar. This would not work on Google Colab. So you cannot actually, this button, so all the full screen button is disabled on Google Colab. So if you really want, you can right click here and then view output full screen. So in that way, now you can see this one full screen, but it's not going to take the whole vertical space. So if you really want, then you can set the width. So let me show you. I'll just press escape on your keyboard to return to the original one, and you can make the height equal to, for example, 1000 pixel. So if this is something that you want, you can increase the height so that it becomes the height becomes larger. Then you can read the full screen again. So now it should do a little bit better. So if your map is like having a lot of data, this is the way that you can view the full screen. Again, this one doesn't work. So again, press escape sign to return to the original one. And let me remove here the height. So I'm going to run again. And the only thing kind of different from the MapLibre that is, so the MapLibre, because it's a 3D mapping library, so it allows you to specify pitch and bearing. So if you don't know what does that mean, you can press Shift tab. No, I think when you hover your mouse on the map, you should be able to see. Interesting. So it doesn't show up automatically. I'm going to switch to my local Jupyter lab so that I can show you some of the help documentation. So again, I already installed this one on my local computer, so it's pretty much very similar. On the left side here, I can turn on this table content, so it's easier to navigate through. And I'm going to run this one, the same thing here. So for this one, I can just press Shift on your keyboard to bring up the documentation. So the bearing and also the pitch, by default, they're all zeros. The pitch means basically is the measure in degree away from the plane of the screen. So from 0 to 85, and the bearing is measuring degree counterclockwise from the north. So what we are trying to do here, let me show you. If you press Control on your keyboard, and then you drag your mouse up, you're going to see something like this. So right now what we're doing here is we are changing the pitch. So right now this is 0. So from 0 to 80 something degree. So if you change, for example, a little bit tilted like this way. So for example, from this probably is maybe around 60 degree. And the bearing is counterclockwise. So right now we are pointing north. So if you drag this one, turning this one around. So right now this is increasing. So this is what the bearing mean. So if I change this one, for example, pitch to 60 and maybe the bearing to 45, and notice what's going to happen. So if I run this one again, you will see right now this is the map is rotating to the left, right? So it's counterclockwise 45 degrees. So this will be 0, and then this may be increasing, and then this is right now roughly 45 degree. And also the pitch is 60, right? So basically you are looking horizontal rather than looking right. This will be just like overhead, you're looking at the map. So if you do it like this way, it's going to increase from 0 to 80 something. So if I don't want to tilt it too much, you can change to 30 and then change the bearing, for example, to 0. So this is how you can control. It's probably a little bit too much. So I can change it, for example, to 45. It's going to tilt it like this. So if you run it locally, then the full screen button should work. And this is actually a lot better. Anyway, so this is how you can create an interactive map. So by default, if you don't specify anything, it's going to center around the globe, and 0 and 0, and also the pitch and bearing, they're all 0. So make sure that you hold your control key, and then you can turn around. So right now, because this map is just a 2D map, so you don't really see any benefit of using this way. But later, when we create 3D maps, you will notice how powerful it is to render different features in 3D, for example, buildings, trees, or other type of stuff. So this is certainly something a lot more powerful than the MapLibre. But it's a new package, so it's still under active development. Then not all the functionalities that are available in MapLibre that will be available in the MapLibre package. So by default, you can create a map and then using a dark matter base map, but there are a couple more like vector tiles. So keep in mind, these are all vector tiles. So it's very, very different from the raster tile. So one thing the vector tile is like you can zoom all the way in and it's still very crispy and sharp. So for example, I can press shift on my keyboard, and then you can drag a rectangle to zoom into the area. So for example, I can zoom into New York. So press shift on your keyboard, and then you can keep zooming in, right? So you can certainly notice this is a lot better than raster tile. But right now, because this is dark matter, so you don't really see a lot of differences. But again, you can zoom in. You can zoom into very, very high resolution. You don't really see any pixelated effects. And this is because it's vector tile, it's not raster tile. So for raster tile, when you zoom in to a certain level, you're going to see the pixel, it become pixelated, and this is not. And later, when we use some other better base map, you want to see a lot more better. But right now, it's just the dark matter, the default ColorDB base map vector tile. So how do we change the base map style? And leaf map already have some vector tile built in. So all we need to do is just to specify this style parameter. So here, I'm going to press my keyboard, shift on my keyboard, and you can look at the style. So by default, it's using the dark matter. So this one, you don't need an API key, so it's free. But you can use another one, position or Voyager or Liberty. So there are a couple more available here. So we can use the position. So if you want a light version, then might be the one that you want to try. Again, if you zoom in, you should be able to see also very high resolution. So press my shift on your keyboard, and all the data here are built on top of OpenStreetMap. And this one actually we can see a little bit 2D. It's a little bit extruded, but it's not too much. So this is just a lighter color base map. And the other one that I really like is the Liberty style from OpenStreetMap. So this is a new web map service. It's free, the vector tile that you can use for any commercial applications. And they only provide these three positions. So it's similar to the ColorDB position style. They also have Bright and Liberty, also 3D. So the 3D one is really nice. It's kind of similar to Google Map, but it's free, so you don't need to get an API key. You can use it for whatever purposes. So what we're going to do here is going to just create a base map and then just change the style to Liberty. Then you're going to have this map. So by default, it looks pretty normal, just like this would be the simple base map. But if you zoom in, you're going to see a lot more detail. So again, I'm going to draw a rectangle to zoom into, for example, New York. And where is it? Okay, here. And I'm going to zoom in. Right, so this looks like Google Map. The style actually look very much similar. Again, it's based on OpenStreetMap, but you can customize the style. So if you zoom in to a certain level, you're going to see the buildings. And the nice thing about this one is it has 3D, so it's extruded. This is where you can hold your control on your keyboard, and then now to see the 3D, see how cool it is. So essentially, we're just using 2 lines of code, and then we can create a 3D map like this. Right now, the color is all gray, but later we can actually change the color based on the height. So it's going to look so much better. But this is free data set that you can utilize for your web applications. And the buildings are really nice. They all have 3D heights. So this is why you can render. You can change everything. And this is at a global scale, so it doesn't have to be in the US. You can do it for anywhere in the around the globe. So for example, I can go to maybe here to the United Kingdom, right? And you need to zoom all the way in. So I'm going to maybe look at London. So zoom in here, and depends on your internet speed. So when you zoom all the way in, you should be able to see the 3D buildings as well. And then you can turn around. So you have all these labels that are very dynamic. So this is the power of the MapLibre Python package, also the MapLibre JavaScript library, because it was able to render these kind of vector tiles very, very easy. And 2 lines of code. Of course, you can customize, so you can change the center, the zoom level, and also change the pitch and bearing. So when you create the map, you will load this one. So we're going to show you more examples later, but right now just give you some flavor how easy it is to create interactive map easily. If you don't want the base map, you just want some like background color, you can also change the style. For example, background hyphen and then light gray, green, or red, whatever you like. Then you can also create just a simple base map. For example, if you are showing something, you don't want the base map to interfere with what you're trying to show. So you can change this color to whatever color that's common color. For example, change it to green. Then you can create a green empty base map. I can change it to maybe red as well. So gray. Okay, so it's up to you what you want to use. So you can just use whatever keywords available. For example, dark matter, position, liberty, voyager, whatever you like. And if you have a vector tile, you can also pass in the URL. So the style parameter accept a string of a style, or you can accept like HTTP URL. So for example, this is demo vector tile from MapLibre. So if you copy this one, put in the browser, you should see it's actually just JSON file and then describing what it is. So this is something we're going to cover later. It looks pretty complicated and very lengthy. And this is just basically all the vector tile describing how the different data layers that is going to be rendered on the map. So if I run this one, you should see this is a simple map. It's not very detailed. It's pretty colorful. And so it's a vector tile. So when you zoom in, it's still very crispy and sharp. So this is so much better than using raster tiles because it preserves the resolution, and the resolution doesn't change when you zoom in. So it's still very high resolution. Okay, so this is how we create a simple base map. And by default, you will notice in here, we add this zoom control. And also, basically, this is the navigation control. So zoom in, zoom out, and also the full screen control. But you can also customize the control. So here, I'm going to show you a couple more controls. For example, the geolocate. So what you can do is create an empty base map, and because by default, we're already adding this control, so you can add another one called geolocate control, and then you can set the position where you want to put lower left corner, or top left, top right, or bottom left, bottom right. So those are some of the common positions you can have. So if you press Shift on your keyboard, the position, these are some of the positions you can have. So you can scale control, full screen, geolocate, navigation control, attribution, and also the draw control. And you can run this one. So this is very much similar when you use some web applications. It's going to ask you whether you want to allow the web to access your browser location or not. I'm not going to run this one because you're going to know where I'm located, where my house, because I'm not teaching at the university today. So I'm just recording this one in advance. And so the second one is the full screen control. So if you don't want to enable this by default, you can, when you create a map, what you need to specify is this one. So just the control and then the square brackets. And so you're going to have this one. By default, you're going to turn off all the controls. And then you can use the add control and then give us name of this full screen control. Then you can specify where you want to put this one. I think you need to change this one maybe to the liberty, because the switch, this one comes from MapTiler we haven't covered yet. So if you run into any errors, just change this one. So to Liberty, and I'm going to run this one here and take a look. So now we have this one, the full screen here in the top right corner. And so the navigation control is gone, just this single full screen control here. You can change it to somewhere else, for example, top left, then it's put on the top left. So make sure that you set the control to just a curly bracket. That means it's going to just turn off all the default controls. You can also add the navigation control, very much similar. So I'm going to add the same thing. The navigation control, we turn it off by default, and we also add it again, put it on the top left corner. So these are some of the basic one you can change. So if you don't like the control to be in the top right corner by default, you can turn it off, and then you can put it on the left side or lower left or whatever you want to put in. So these are the basic one. The next one, more advanced, is the draw control. So the draw control is allow you to draw different shapes or geometries on the map. So we're going to create a map, and then you can call this function add draw control. The position we're going to put on the top left. So I'm going to run this one. So this is the new one, right? So because by default we create the map and we don't turn off any control. So you're going to add this navigation and also the full screen control by default. On the left side, this is the new one, basically the draw control. And so you can use this one to draw anything on the map. So this one is a line. You can just click here, something like this. You're going to create a new line. You can also use this one to draw basically a polygon, rectangle, something like this. And when you double click, it's going to finish. So you can click here on the map somewhere else, then you're going to deactivate. If you click again, it's going to select this one. You can also place a couple points here. So when it's kind of brown color, that means it's being selected. So if you click somewhere else, then it's going to deselect. And so if you want to select to modify the object, you click the map, and then you want to click the vertex again, then it's going to be made bigger, and now you can drag that. So this is how you can modify the geometries interactively. You can also drag this one. So by default, it's going to add a new vertex in the middle. So for any line, if you see when I click somewhere, it's going to have this kind of smaller one. So these are basically it's not the vertex you can create. When you click that, it's going to create a new one. So if I click this one again, then you can drag this one. So I can click here, I can drag, and click here, I can drag. When you're done, just click your mouse somewhere else. Then you can create, it's going to be saved the edits, right? So this is really easy to use, very interactive, and looks pretty nice. So again, I'm going to click this one again, and I can drag here, drag here, drag here, click again, and it's done. So I can click here. You can also click this one, the delete. So if you don't want it, you can just select it and then delete the button, something like this. So again, delete. So this is how you can utilize the draw control. And if you want to customize, for example, this is by default, adding this line, polygon, marker, delete, and also the combine and group. But if you want to customize it, you need to use the MapLibre draw options. So here we create a map, and then you can create a draw option. For example, display the controls default set to false. That means right now we want to customize it. Then you can specify what control do you want. Right, the map box draw control, you can set the polygon to true, the line string to true, the point to true, and also the trace to true. That means we are turning off these two buttons, the combine and also the ungroup. So this uncombine, so these two we don't want it. Then you can just put the draw option. So when we add the draw control, if you don't provide any options, it's going to use the by default or everything. So right now we provide a draw option, just saying we just want these 4 buttons. We don't want anything else. And so we just want this 2 code block. It should work now. So see, now we only have 4 buttons rather than 6. Besides that, when you add the draw control, you will see the parameters in here. So Shift tab, you can actually pass in the GeoJSON. So it's useful sometimes if you already know you want to create some default geometries. You can load it when you add the draw control. So you can specify, for example, GeoJSON. So this is a GeoJSON dictionary with 2 features. One is a polygon, 2 polygons, okay? And these are basically the vertices. So we have 5, and this one has 7. And this is a GeoJSON, so it's a dictionary. So you can just use this draw control, and you can pass in the GeoJSON. So in this way, when you execute this one, you should be able to see we have these 2 polygons in here, right? So in that way, you don't need to draw them only by yourself. You can load the default geometries, and then so the user can just use these directly. If you want to select, just click here, and then you need to click one of the vertex again. So make it larger. Now that means this one is being selected. Now you can draw, change it. So I'm going to draw this one here, something like that. So similarly here, I can add another one. I can add a point here. I can drag this one. I can drag this one. I can drag this one. Once you create the polygons, you can also access the features. So for example, these are the 2 polygons right now, and you can use this one, draw feature selected. Right now, there's nothing selected, so you're going to see an empty list. But if let me remove this one. If I select this polygon and run this one again, you will see it's being selected. So here we have 1, 2, 3, 4, 5, 6, 7, 8, right? So if 8 vertices, actually 7, 1, 2, 3, 4, 5, 6, 7. So the first one, the last one is the same, and this is the one being selected. You can actually edit the feature. So for example, here you can draw it, you can add a new point, you can add a new point. So certainly this one right now we have a lot more points. And after you finish, just click this one, it should be saved. If I run this one again, you should see more points. So take a look. Oh, it's not selected. So let me select this one. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So I added just 2 more points. And so this one, if there's something that you want to edit and then you want to get the draw geometries to your program to do computation, then this can be very, very helpful. So you certainly want to utilize this one. But if you want all the features, so for example, all the draw features, not just selected. So right now I don't select anything. If I run this one, it should return 2 features, right? So this is the last one that we just edited. This should be the original one. So we have 2 features being selected. So you can see an ID, basically just ABCXY is the one coming from our original ID in here. So it keeps all the property, all the features, but allows you to edit the features. So this can be particularly helpful if you want to create some features or geometry on the map, and then you can use that to do computation. Okay, so this is how you can add some map controls. Again, there are a couple of these available, so you can turn it on, you can turn it off, or you can add the draw control. Next, let's talk about how we can add some data layers. So by default, we can just create a style and then create the map and then assign the style. But sometimes some of those we want to utilize some additional data layers. So the vector tiles is very powerful, it's very nice, but sometimes you might still want to use some raster tile. So this is where the app-based map function can be helpful. We have covered that one previously in a leaf map, and also you can all the leaf map previously, all the base map, actually that's the same thing is also available in the MapLibre. So you can just call the same base map function, and all the base map here. Right now we don't have the drop down list, but all the names is equivalent. So you can also find them from here. So I'm going to run this one, just see what happens, right? So we by default is creating the map and then using the dark map base map. Then you can use the add base map function. So these all the names that are available in the leaf map, you can just add it. Also, there's a new one here called add layer control. So this is the one here in the upper left corner. So this one is the layer control. So if you turn that on, it's going to be highlighted in blue. If you click again, it's going to be white color. That means it's turned off. So, right, so because we add just one data layer, open topo map, and so right now it's off, you click again, it's turning on. So this can be helpful. You have many data layers, you want to turn some layer on and off. So similarly, you can call the base map. So the nice thing about the MapLibre package is that it's similar to IPy leaflet. So you can modify the content of the map. So the map has already been displayed, but I can continue to add something to it. So I can add another base map called Esri wall imagery. So of course, this button right now, this add layer control, it is not working properly. So because the layer is supposed to be added, but it doesn't update the layer control. Hopefully in the future it will be fixed. So this is just right now showing you we can add the base map, but again, these are raster tiles, so it's not a schematic map like vector tiles that you can continue zooming. To a certain level, you're going to see it's pixelated, you cannot zoom in anymore, so the layer will not, you cannot zoom all the way in, and at a certain level it's going to stop. It's going to be look a little bit fuzzy. And so right now it's loading. It should be high resolution like this. This is a little bit coarse, so you depends on the internet speed. Okay, so this is the best we can get right now. And if you try to zoom in, then it says okay, map data not available because it doesn't support that high resolution. But still, this is probably centimeter level resolution. It's already high. But again, if you turn off that one, or this one doesn't work yet. Anyway, so how do you know the base map name, right? So what you can do is just create an empty base map and then just call this function add base map. So by default, if you don't specify anything, it's going to show you an interactive graphical user interface. So it's going to show you here, this one at the bottom here, and then you can select from drop down list. So this is very much similar to leaf map, the IPy leaflet backend. So by default, you're going to have this Google Maps, ColorDB, blah blah, right? So I can change this one, for example, Google Terrain, and you can turn this layer on off. You can also change the opacity, right? And hopefully in the future I can integrate this one to the map. Right now it's not possible yet because this is still a new library and this is all based on TypeScript and JavaScript. This one is based on Python. So right now the tool, you cannot integrate this one directly in the map yet. But at least you provide some way that allows you to do some changes. For example, I can change this one. I can change to Esri. I can use, for example, open topo map, open file map. So if you need some base map, this one can be useful. For example, USGS base map, right? So pretty cool. And you can change the opacity to, you can turn it on and off. So this is just a built-in base map, but sometimes if you have some other web map services you want to add, for example, XYZ tile layer, or it can be WMS, web map services tile layer. So the first one is XYZ. So XYZ tile layer basically you just need a URL like this. And this one comes from the nationalmap.gov. You can call this function add map.add tile layer and then just passing the URL. The URL basically is just this one, and then you can specify some other parameters, the opacity, the zoom level, and something like that. So I'm going to run this one. So this is the US topo map. It's not available through this one here. Oh, it does. So the US is US topo. So let me show you here. Okay, same thing. But this is we're doing that using the interface. But there are a lot more base map available here through the nationalmap.gov. And we're adding, just providing the URL. So this URL, if you have your own web map services, you can just pass this one in and then you can utilize it. So similarly, you can use a WMS layer. So WMS basically means you need to provide a layer, WMS. Besides the URL, you also need to provide the name of the layer. Then you can call this add WMS layer function, the URL and then the name of the layer, and whether or not you want to so the before ID means that you're going to place beneath this one. So the before ID, because this is a base map, so without this one, the image is going to basically place on the top. So let's remove this one to show the differences. So if I don't have this is going to place on the top. So in this way, it blocks all the labels because the base map beneath is a vector tile. So it has all the labels. And it'd be nice that you can place the label on top of the raster image rather than right now you don't see any label, so you don't know the location. And this is where this one is very useful, the before ID. So that means, okay, in the base map, there's one of these data layer. So we're going to put this one before, basically beneath the labels, right? Field, the row, basically the row network, not just the label. So, right. So this should be, the 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 transportation network. So it creates the imagery beneath the transportation network, and you can turn this one on and off. Take a look here. And it's pretty nice. So you basically think about the vector tile has a lot of data layers. You can insert the layer into a certain label, and then you can see the label. So if this is something you want, you can certainly try it. This is not available in MapLibre. Okay. Similarly, we can add another one. For example, the national wetlands inventory in the US, right? So also you need this URL and also the layer. So this is basically you need to look into the metadata. Sometimes it's the name of the layer, sometimes 0, 1, 2, 3, 4, 5. And so specifically for this one, it's called layer 1. And we're going to give a layer name here, basically the NWI, so I can turn it on and off. We're also going to get add the base map and then add the layer control. So this will be the layer control. Also the add legend. We'll cover more later. So the add legend allow you to add one here in the lower right corner. And div map has the built-in legend. So similar to MapLibre, we can also just use the built-in legend. So just one line of code, you can add something like this to the map. And it's very cool. So this is showing you all the wetlands. So you can zoom in, you can see the detail. You can load the maps on the fly. So this is using the WMS web map services, and you can turn this one or rotate. Right now it's not 3D. Later we can actually overlay this one on the 3D if you want to. So this is better than just using the 2D visualization. So you can see things in 3D. You can rotate, you can zoom in, you can zoom out. Okay, so this is how you can add some base map services. And so the next, I'm going to show you how to add raster tile, because these are all vector tiles, and also the one we just covered using some base map and XYZ WMS services. But there are some other raster tiles. So if you want to, if you have some other URL, you don't. For example, specifically for this one, if you don't know what kind of tile it is, you can just create your own data source. So this one is basically utilizing MapLibre, the package like specification, and what you need to specify the style, right? So if you remember, when we create a map, we need to specify the style. So the style you can customize. So specifically for this one, we can specify the source is a raster tile. And then the URL, the tile come from somewhere. Also inside here, it has different data layers. So when you use the one data layer, so the source basically is the data source, and the layer is going to come from rely on this data source. And then you can specify, for example, the zoom label, blah, blah, something like that. And this can be a little bit complicated for beginners, but if you want, you can go to basically the MapLibre the documentation. And if you go to maybe the style specification, and then go to sources, so this one will show you all the sources, different sources available. For example, raster source, raster DM, and then raster tile, video, images. So the one that we are talking about is actually this one, raster, the type. And the raster resolution, you can have the tile, the scheme, and blah, blah, something like that. So it's come from here, raster tile, raster data layer. And so you also have the vector tile, raster DM, GeoJSON, so video. So those are some of the different data types that supported my MapLibre. So you certainly need to, if you want, you can customize it. But it's going to be a little bit more complicated. Most of the time, you can just use the map.add WS or add XYZ or add base map. That should be usually enough. But in some rare cases, if you need it, so for example, we can add this ocean watercolor base map and basically customizing the style, then you can add this one to the map. Okay, so this is what I want to cover about some basics using the MapLibre Python package to create maps, add base map. And since we're using vector tiles, there are only a couple 3D available options available. For example, the Liberty one and also the ColorDB, but there are some commercial version available. So this is available through the one called MapTiler. So MapTiler is basically a company that provide vector tiles. So you can just use your own API key, and there are a lot more options available. Then you can just utilize that directly within LeafMap. So in order to use that, you will need to sign up for an API key. And so what you can do is by going to this URL. So click, it's going to take you to the website. So from here, you can just sign up using a Google account. And so I'm going to turn this one on and then log in. So once you're logged in, you might need to enter your credit card. I forgot if I need to do that or not. And after that, you should be presented with this interface. And it's going to show you, for example, the data analytics, how much have you utilized, for example, here, how many tiles, how many requests. And I think for the free version, they provide some limit. So usually it should be enough unless you are publishing your maps on the web for the public to utilize, then it might exceed the request. If you're just following this lecture, it should be fine. So it's free. You don't need to pay anything. And in order to utilize the MapTiler style, you need to create an API key. So come to on the left side here, click this API key, and this is where you can create API key. And the API key is very important, so don't expose your API key. After this lecture, I'm going to just replace. So the API key that now you're seeing is going to be invalid after I replace this one. So once you're presented on this API keys web page, you probably just have the default one. So you can just use this one. For example, I can just copy this one. And then you can come back to here, uncommon these two code blocks. Okay. And then just replace this one with your own API key if you're just doing it yourself. So this is setting an environment variable, MapTiler key, and then replace this one with your API key. Or you can create a specifically create a new one. So for example, you can say new key, and then for example, testing. Here, if you want to deploy this one on the certain website, for example, your own domain, for example, examples.com or something, whatever custom domain that you have, you can write this one so that other people can use it. So it only can be served on a certain website. So if you need to publish your website later, I'm going to cover this one at the end of the lecture. Then you do need to specify this one. Otherwise, you're going to expose your private key. So make sure that you understand that. And so once you have this, now I can run this code block. So in this way, we are setting an environment variable. And after that, if you run this one, you should be able to see all the web map services. So these are the base map, all the base map available that you can utilize. Again, I can go to this website and the maps. So these are all the base map available. So you can click this. So we're going to use, for example, the suite come from here, all lowercase, or satellite, or topo, or ocean, OpenStreetMap, blah, blah. So this OpenStreetMap should be vector tile. So it should be, if you zoom in, it should be higher resolution, I believe. So for example, here, I'm going to center, and so this is different from the OpenStreetMap that you see directly from the website. This one is vector tile, so it's better quality. Okay, and after this, you can use any name of this thing here. Just replace the style with the name. So LeafMap makes it really easy, so you don't have to do a lot of like copy the URL. It's kind of complicated. So you can use street, you can use satellite, and also there's a hybrid. So satellite is just the satellite imagery. You can use this hybrid. Hybrid means you have the satellite, you also have the label. So this is similar to the Google hybrid, right? So you have satellite imagery and also have label. You can also try the topo, right? Topographic maps. And again, you can use any name here. It doesn't, so we only show you four. For example, you have the basic, you have the landscape, you can have outdoor. So you can change it whatever you like. So I can change it to outdoor. It should be outdoor, right? I can change it to landscape and run it. You should have the landscape. So there are a lot more base map available that allow you to access. And so this is something that you might want to use. If you don't want to create an API key, you can use most of the things for free. If you need the 3D, then you use the Liberty style. Otherwise, you can use the position or the voice or just the dark matter. The next one you can use is the vector tile. So here you can just get any vector tile. So this is be the one from here, the tiles. And like I said, MapTiler also provide some of the vector tiles available here. So you can utilize some of these. So for example, for the contour, right? So this is the contour, and this will be the vector tile URL, right? So the API.MapTiler tiles contour v2 tile JSON, and then at the end here is going to attach your API key. Again, don't expose this one, otherwise people can abuse your free services using your API key. And this is what this one is doing in here. So we're going to attach this API key. So what you need is just a URL. And because this is the vector tile, so the type is called vector. And then, so this will be the data source. And you can specify, for example, the layer. So I'm going to use this data source. I'm going to use the contour layer, and I'm going to render as line. And you can specify basically the style, how you want to, the layout, and also the style, the color. After that, what we can do here is add source and add layer. So this would be the add source, means you can have one data source, you can have multiple data source. So the add source is going to add this one to the map, and then you can add the layer. So add the layer, so you can have multiple layer depending on the same source, basically different representation. So also you need to use the div.map.get API key function, so you can replace this one within this here. And if I run it, oh, I need to run this one. So right now you're seeing, right, we are adding the contour maps to the base map here, the street, right? So pretty cool. And this is vector tile. So you mean zoom out is going to basically, because they set the zoom level, so it's going to be simplified. But when you zoom in, you're going to see a lot more data layer. Again, you're welcome to use any of those in here, any of the vector tiles. You can also do countries, for example, and you should be able to render all the country. So just similar, but you do need to know like what data layer is available, so that you can learn more about the tile set, different tile set. So these are all the vector tile concepts. We won't be able to cover in detail about all the tiles in here, but the methodology is very much similar. So you can use the vector tile based map, and then you can add additional vector tiles on top of that. So this is how we can utilize MapTiler. And next, I'm going to show you how we can use some 3D. So far, most of the maps are still 2D, but how can we actually utilize in the 3D? So first, let me show you this one, just this 3D terrain example. And I'm going to show you here, this is around, I think, Mountain St. Helens, so in Oregon, right? So this is right now 3D. So if you press Control on your keyboard, you turn around, this is real 3D. Not real 3D, still 2.5D, I think, but it's much better than just 2D map. So you can drag and drop and zoom in and zoom out. So for this one here, if you take a look at this, it's also very simple, easy to use. So you can just put 3D hyphen prefix any of the style that we have used earlier. So again, let me go back to the maps in here. So all these base map, all you need to just put 3D hyphen, and then after that any of these name in here, then you will turn that one into 3D. Because leaf map makes it really easy to use. And so after that, you can see we have because this is hybrid, and there's also a hue shade. So you can turn the layer on and off. There's a hue shade layer, for example. Take a look at this. There's a hue shade layer beneath the hybrid base map. And the reason basically we are extruding the data layer based on the hue shade data layer. And this is super cool. You can zoom to any locations. Also the add layer control here, there's one option called background layer. So right now this hue shade data layer is the background layer. By default, it's not adding the background layer. So by default it's false. So if you really want this one, you want to see this one, then you set the parameter background layer to true. Then it should load all the data layer. So this is 3D hybrid, right? So you can zoom into any location. 3D hybrid means you can have labels. So that's why you still see this label in here. So you can turn into any location. So this is all 3D, super cool. So what we're doing here essentially is just 2 lines of code. So we can create a map, specify the pitch and the bearing, and also the style, any 3D style. Then you will see something like this. and it renders pretty fast, so it can be anywhere. Essentially, it's rendering the 3D on top of the hillside, basically the DM, and it's drag the satellite on top of the DM, so it looks really cool. You can also just use the 3D satellite, right? Like I said, if you don't want the label, then right now you can use this one. You will just the satellite imagery without the label. So now you don't see any labels on the imagery here. Also, you can do 3D topo, for example, 3D topo map. So it's the same location. So right now we're using this one, so the topo map, and so the background layer equal to 2, and we can also change the extrusion. So the exaggeration is basically how basically 1.5 multiplied by the elevation. So by default it's 0. That means we're not exaggerating the height, but you can change this number. For example, I can change it to 3 and see what happens. So you're going to see it's much more extruded. It's more extreme because we change the height. So look at this, super cool. And but you might also like you can use everything has been extruded a lot. So this is overlaying the topo map on top of the hillside. So the hillside equal to false. That means we don't use the hillside, but you can turn it to true and to see it. All right, so right now the hillside, we turn it on, so you can see it's right in here. So beneath, this is the hillside being used to render the 3D topo map on top of the hillside, right? You can change it to any data layer you like. For example, you can change it to maybe how about maybe the landscape, right? So we can also change the 3D landscape as well. So I'm gonna change this one, landscape, and run it. All right. So very easy. So you can use any style. You can render it using 3D. So this is one example, but there are a couple more. For example, 3D terrain. So this one is similar to the 3D satellite, except that right now we have this hillside beneath it, and you add the layer control, the 3D terrain, 3D hybrid, 3D satellite, or 3D landscape, whatever you like. The last one I'm going to show you here is called 3D ocean. So we also have the ocean base map in here. This is the one. So 3D ocean, that means you can render this one with 3D. So if you look at the ocean, for example, zoom to this location, and I'm going to look at maybe the Mariana Trench. So if you zoom in and then press Control on your keyboard, then you can see the bottom of the ocean. So this is also 3D. So if you want to do the 3D ocean topography, this can be useful, right? I can zoom in, I can zoom out, I can turn around, super cool. So pretty much all the base map, you can drag it on the hillside and to turn that into 3D. If you need to reset this one, you can click here, it's going to reset it. So if you have the hillside, you're going to look, when you zoom out, you're going to see something like this. If you turn it off, it's going to be less obvious. So right now you don't see those hillsides beneath it. Oh, you still have, but it's less obvious. So now you don't, in the ocean here, you don't really see that obvious because the hillside does make the 3D visualization better. Last one is about 3D buildings, and this one is a lot more complicated here. So MapTiler provide the vector tiles, and the vector tiles have buildings. So building, some of those has height attributes. So for this one, we're going to create a map, and then we're going to get the API key. We also want to add the Esri wall imagery based map, and this is the source. So as I mentioned earlier, you can add the data source and then you can add the data layer. So the data layer comes from the data source. So this is using the MapTiler API, the vector tiles, and this is the data layer. So take a look at this one. Basically, we're using this data source. So the data source is from this open map tiles, and So we're going to use the basically give this ID called 3D buildings. Then we're going to use this so-called field extrusion. So this is the layer type. Again, this all come from MapLibre. So if you go to the layers, then you can see field and then field extrusion. For example, this will be the layer type. So if you have polygon and the polygon has some attributes that you want to use it to do 3D visualization, then you can use this field extrusion type. And the minimum zoom and also the pen. The pen basically means how you want to render the field extrusion color and the height and also the base. So what this one is doing here is we're going to get basically the height, the render height basically is within the data set. So it has this attribute, and so if it is the height is 0 to 200, it's going to use the light red color. If it is 200 to 400 level, it's going to use the royal blue color. If it's greater than 400, it's going to use the light blue color. So basically means that for different building height, you're going to get a different color, and also it's going to do some interpolation between. So from 15 zoom level to 16, it's going to do some interpolation, linear interpolation. So you can, when you, for example, zoom level less than 15, it's not going to show up. From 16, it's going to be fully show up. From 15 to 16, it's going to do some linear interpolation. So if you run this one, and let's take a look. So then this example is a little bit complicated, but we'll show you how to make it easier, right? So for example, right now, if this not with 15 yet, so you don't see it, when you zoom in continuously, now this is where it's going to basically interpolation here, right? You can see up and down, and it's super cool. So you can turn this one around, you can see all the 3D buildings. So now the color you can see, if it is lower than 200 meters, it's going to be gray color. If it is 200 to 400, then you want to have blue color. If it is greater than 400, then you're going to see this color, like a light blue color, the royal blue color, the light blue color. So 200 to 400 is royal blue color. And so this one certainly is much higher in here, and you can zoom in, can zoom out. Again, this is at the global scale, so you can use any location. You can zoom into any location that you like. Okay, so this is how you can add 3D buildings using the vector tile, but the easiest way would be using this one. The same, basically, we're trying to do the same thing, but this is just calling this function X 3D buildings, and that's it. So you don't have to mess around with the vector tiles. You can just use the default one. So let me show you here. We just run this one, you should get the same result. So we just set the minimum, the zoom level is 15, but you can change it. Also for the color, you can customize the color. For example, the value from 0 to 400, 0, 200, 400, you can also change the color. So if you want, you can actually customize it. So for example, here I can change it to colors equal to, and then square brackets, and I can do maybe red, green, and then blue. Okay, so take a look, red, green, blue. So red means it's from 0 to 200 meters, green means from 200 to 400, and then blue means it's greater than 400. So you can customize to whatever color you want. It doesn't have to be 3 classes. You can add more. For example, you can add 4, maybe another white color, for example. But if it is more than 4 color, you also need to set the change the height. Right now, it will not work because the lengths are not the same. So here you should customize the value as well. So it should be 4 values, 4 colors. And I can do it here, for example, values equal to square brackets. Okay, so you can do maybe 0 to 50 meter, for example, and then 50 to 1, oops, 0 to 50, 50 to 100, and then 100 to 200, something like that. So it's up to you how you want to customize it, but certainly right now for anything greater than 200, you will see it's white color, and it's very colorful. It's very beautiful. Take a look. Super cool. So all you need is just 1, 2, 3, 4, 5 lines of code, then you can create this kind of 3D maps. And later I'm going to show you how you can export the map, and then you can put it on the website, so you can render it anywhere you like using your own API key. And if you use JavaScript, it's going to be a lot more complicated. Right now using Python, you can also turn on this edge-based map, right? So this will be what it looks like. If you look in like overhead, look down, it's going to look like this. So right now I have all the buildings. Turn the buildings on. You need to zoom in so you can see the buildings. And again, I'm going to turn this one on, and you're going to look something like this. So super nice visualization. So this is using the 3D buildings, and this is all using the OpenStreetMap data. They have the height. We can also do indoor mapping. So again, I'm going to show you this example is doing the indoor mapping. So you can have a GeoJSON file, and the GeoJSON file might have some height. So when you use the geodata, convert the GeoJSON to geodata frame, and then you can take a look at using the Explore. So right now this is using a volume. You will see here you cannot turn it into 3D, and this is using some sample data set. We can take a look at what information is inside this geodata frame. So it has the height, also the base height. The height means basically for every polygon, it has this height attribute. So it's up to you what you want to do. Also there's a color, so you can actually render the height based on the specific color. So if your dataset support something like this, you can also do it. So for this one, we're gonna use this called add GeoJSON, and then the GeoJSON come from here, right? So we're gonna basically just HTTP URL. You can just pointing to the HTTP URL. So the data pointing to the URL. The layer type, we're going to use the field extrusions. Again, anything you want to do in 3D, you want to extract the extrude the polygon, you're going to use this layer type called field extrusion. Again, it comes from this layer type in here. And so for this specific layer type, these are all the properties you can set. Field extrusion, opacity, color, pattern, height, something like that. So here, the color, we want to basically use the get color. So square brackets get color means you can either specify an absolute number, or you can get for every feature, for every polygon, something in here, we can get the color based on the column. So basically means for this feature, you're going to get color based on this color column. So this will be orange, green, gray, whatever you like. And the actual height is going to be based on this one, this height. Also, there's a base. So sometimes by default, the base will be 0. But if you have a building, for example, already have some data layer, you want to on top of that, then you can set the base height. For this right now, it's all 0, but it doesn't have to be 0, right? So let's run this one. And this is it. So take a look. You can control, you can zoom in, you can zoom out, and you can also see the color. So basically the floor color, right? It has the color from this one. And compared to the one using volume, okay? So this is just the same color. It's not 3D, so you cannot use press control to see this one 3D. But right now we're using this kind of indoor mapping. And so we're gonna basically place the building on top of the OpenStreetMap, and very nice, right? So just a couple lines code, we can create this kind of 3D maps easily. Besides the indoor map, the last one I show you here is called 3D choropleth map. So this can be useful. Sometimes you use desktop GIS to create some of those maps to showcase the differences within different features. This one can also be useful. The source code looks a little bit lengthy, but again, it's basically adding the data source and then adding a layer based on the data source examples, right? So add the layer, add the source. So the source is coming from this GeoJSON file. So this one shows you basically the European countries age at first marriage. So that means when do people get married at their first marriage in the European countries. So you can indicate, for example, which country like people get married at very young age, or maybe at older age. So this is just GeoJSON file. So we just create a dictionary and then tells, okay, this is the GeoJSON. Then you can add the data source to the map. So the data source is going to be named countries. So this will be the name of the data source. And then you need to specify here the source, basically the country. So the name here need to be the same as this one. And after that, you can give an ID. The ID basically is just the name of the data layer and then what data type. So we're going to use the field extrusion. Then you can use the pen. So the pen, again, is coming from, so for all the data layer, you're going to have the pen. The pen allows you to specify what you want the color, right? So this is the field extrusion. So basically all the data layers here, the pen will basically means anything within here can be specified in the pen. So I'm going to use the interpolate, a linear interpolation, get age. So basically means this data set, the GeoStation file, already has the age, so the average age at the first marriage. Then you can specify, for example, 25, 23 this color, 24, 25, and then all the way to 30, and then opacity to 1, and also the get height. So this one. Then let's take a look. Right, so super cool. And this one basically means different color. For example, and you can zoom in here, you can see the height. It might not be so obvious, right? So the lighter color compared to the darker color. So darker color means that in those countries, people get married at their relatively older. Lighter color means they get married at a much younger age, right? So this basically shows you the differences. And certainly it looks a little bit more fancy than just the 2D maps, because right now we're just basically rendering just a polygon and then use the polygon to get the height, because for each feature, for example, for each country here, it has the information, has the number, so we can use the number to render the base map height. And one thing that I want to point out here is the first symbol layer ID. So the map.file first symbol layer ID. So this one shows you, for example, if you don't use this, when you add in the data layer, you can, the first parameter is the layer. The second one is the before ID. So it means where do you put, basically you're gonna insert a layer into the layer. So this is what this one is showing here. If you don't do this one, all the label will be blocked. So just similar to what I covered earlier. But run this one again. Take a look. Right now, they don't see the countries because the label by default is going to be put on top of everything on the label. So if you want to insert into different layers, then you can find the first ID. So it's going to show you what this first layer ID it is. So this is going to find out basically the label. Symbol layer basically means just the text label. So what this one is doing, okay, I'm going to put beneath the first label ID, and this is why we can see this kind of effects, and it's so much better than 2D visualization. Okay, so this is how you can render this one. Similarly, there's another example. So this one basically is using the US counties. Oops. Okay, so you can see the color in here, low white color, and also the yellow is color. And this one is the US counties by size. So again, it's just a GeoJSON file. It's data source, and then at the counties, and we're going to use this county data layer. We're going to use the field extrusion and the color, and then do the interpolation. So that means, okay, if the census area, so this is basically the one of the columns within the GeoJSON, and then you have different color, and then you can do the linear interpolation for different colors. So you can change the color in here if you really want to. So right now we're just using this color, but you can change it to, for example, red, green, blue, and white. So let me show you. For example, red will be FF0000, and then green will be 00FF00, and then the last one will be 0000FF, right? Red, green, and blue. And the last one we can change it, for example, to white color. Will be all, white color will be all FF. So 6F. Okay, and then run it. Now you should have a different color, right? Red, green, blue, and white. Right, so that means white color means it has a large census area. For the red color means it has a relatively small census area. And when you zoom in, right, super cool. And so this is basically represent the area and also the label, right? Because we put this one before the first symbol layer ID. So this is where you can see the county still beneath here. Okay, so I think this is what I want to cover in this lecture, and we have gone through a lot of examples. I hope you spend some time practice and learn how to create some cool 3D maps using the MapLibre mapping backend. So in the next lecture, we're going to talk about how to visualize vector data, raster data, and how to do some customization and add some components and PM types and other vector data format. But today, it's enough for you to explore and get started creating some nice 3D maps for your web applications. Okay, I will see you in the next lecture.